Hi, and welcome to this video. Everyone is familiar with the DHT11 temperature sensor, which is widely available for very cheap. Also, it's easy to use and comes with its own libraries for use with Arduino. Now there exists another sensor that can be used to read the environment temperature values, and that is the LM35. Now you must be wondering, why would you go for the LM35 when the DHT11 is already available? Well, for the starters, it has numerous advantages over the DHT11. The LM35 is linear with a 10 mV per degree centigrade scale factor and an accuracy of 0.5 degrees Celsius, whereas the DHT11 has an accuracy of ±2 degrees Celsius. The LM35 is rated for full operation from -55 degrees to 150 degrees Celsius, whereas the DHT11 can only go from 0 to 50 degrees Celsius. The LM35 will provide you real-time data, whereas DHT11 can only provide it every 2 seconds. The LM35 has a higher input voltage range from 4 to 30 volts, whereas the DHT11 has only from 3 to 5 volts. The LM35 is tinier as compared to the DHT11. Now, with all the boring theory out of the way, let's get to the fun part, the electronics. Now, with the flat side of the LM35 facing towards you, the first pin from the left is the VCC input pin. The middle pin is the analog output of the sensor, which provides the temperature readings. And finally, the last pin is the ground and gets connected to the ground of your microcontroller. Now, let's start by connecting up the LM35 with the Arduino. The VCC pin connects to the 5 volts on the Arduino, the middle pin to A0 of the Arduino, and the ground pin to the ground of Arduino. This is our hardware completed. Now further on, an LCD can also be added to this project to display the real-time temperature values, but it is beyond the scope of this video. Maybe in the future I will add an LCD to this project. Now, with the hardware out of the way, let's get to the software. For this, you will need the Arduino IDE, which you can download from the link given in the description below. Start by making sure the correct COM ports are selected and the right board is selected that you are using, that is, the Arduino Uno. Now the code is very simple and easy to understand even for beginners. In the void setup section, we define the pin A1 as the input pin and initialize the serial monitor. In the void loop section, we just use the analog read function of the Arduino to read the temperature. Now here's the tricky bit. The sensor value is not the actual temperature value. To obtain the correct temperature value, we need to multiply that value with a constant. This constant value is obtained by using the datasheet of LM35 and the resolution of the ADC, that is the analog to digital converter in Arduino. Then, using the serial print command, we can print out the temperature readings on the serial monitor. The code can be downloaded from the link in the description below. Now, this is not the end of the project. It can be expanded into even larger sectors, like using conditional statements to trigger another device, like temperature control fan, AC, cooler. Or this could also be embedded in an IoT platform. The possibilities are endless. If you enjoyed this video, please like, share and subscribe, and also tell me in the comment section what projects you would like me to take videos on next. Thank you and have a nice day.